Welcome everyone. The question that is shown on the screen, it is a question of series and parallel. You have to find it out the effective resistance, and this question comes in CBSE 2025 HS grade 12. Okay, so let us read the question. The effective resistance between the points A and B in the circuit is. You have to find it out this. So this is the point A, so let us name it. If this is the point A, this is also the point A. Okay, because there is no resistance in between, and if this is the point B, then this will be also the point B, since there is no resistance in between. So let us name other points. Let us say this is the point C, and let us say this is the point D. So between the point A and C, this 4 ohm, 2 ohm and 3 ohm, all of these are connected. Okay, let us name it. Let us name this is as R1. Let us name this is as R2. Okay, R1 and R2 are connected in series combination, and R3, which is a 3 ohm, that is connected in parallel combinations with it. Okay, similarly R4, which is the 3 ohm here, which is connected in series combination with the 6 ohm R5, and the series combination of R4 and R5 is connected in parallel with the 18 ohm, which is the R6. Okay, and here this 4 ohm resistance is connected. Let us denote it as R7. This 12 ohm, let us note it as R8, and 7 ohm, this is as R9. This is the full circuit diagram. Okay, so let us at first say what is the equivalent between the R1 and R2. So R12, that is simply R1 plus of R2. What is that? 4 ohm plus of 2 ohm equal to 6 ohm. Okay, now R1 and R2 is resolved into 1. Okay, and obviously we can do this. By omitting these two. We can connect this by simply one resistance by the equivalent of these two. Okay, we can do this. So let us say this is that resistance R12. This is my R12, which is the equivalent of R1 and R2. Now R12 is in parallel combinations with R3. So R1, 2, 3. If you want to find it out, you have to take it like that. 1 by R13 equal to 1 by R12 plus of 1 by R3. Okay, so 1 by R12 is 6, 1 by 6. 1 by R3 is 1 divided by 3. Okay, so 6 ohm and 3 ohm, 6 ohm and 3 ohm in parallel combinations. Okay, and this is the formula. Obviously the LCM is 6 here. So 1 plus of 2, we can say that is 3 divided by 6 equal to 1 by 2. Okay, so R1, 2, 3, that is the equivalent of R1, R2 and R3 is simply 2 ohm. So what we can do? Similarly, we can remove all these two, and we can place single one resistor which is connected between the point A and C. Okay, so let us do that. And this is my R123, and that is R123, that is 2 ohm. Same type of portions we will do for R4 and R5. So R45, what is that equivalent of R4 and R5? Since R4 and R5 in series combinations, we can write it down. R4 plus R5, so 3 ohm plus of 6 ohm equal to 9 ohm. Okay, so obviously we can now omit this R4 and R5, and we can replace them by the single one resistor, that is R45. Okay, so this is my R45, and what is this value? The value is 9 ohm. Now R45 and R6 are in parallel with each other. That means this 18 ohm and 9 ohm are parallel with each other. So we can write it down as 1R4 5 6, which is the equivalent of R4 R5 and R6, R4 5 and my R6. Okay, so I am writing down 1 by R4 5 plus 1 by R6. Okay, so 1 by R4 5 is 1 by 9 and 1 by R6 is 1 by 18. So the equivalent will be, LCM will be 18. So these will be 2 plus of 1. So these will be 3 divided by 18. So these will be 18. Okay. So this will be 1 by 6. So very simply now my R456 will be 6 ohm. So I will omit these two and I will just replace all these two resistances, by a single resistor, and that is R6. And that is R6, R456, R456, and what is the value? 6 ohm. Okay. Now let us remember one thing. What we have learned here. We have learned this type of configurations, and here obviously we have said this is P and this is Q. Okay. Sorry. No, this is correct. This is P, this is Q, this is R, and this is S. Okay, and this is G. This type of configuration is known as the Wheatstone bridge condition. Okay, Wheatstone bridge. And in the null point condition, this type of configuration is called the Wheatstone bridge configuration. The null point condition, this G will not work. Okay, will not work. Okay, so in this particular cases, we can write it down: P by Q equal to R by S. P by Q equal to R by S. So in this particular case, let us see this ratio is maintained or not. Okay, this ratio is maintained or not. Okay, see, this is 2 ohm. I'm just changing the ink here. Okay, this is my 2 ohm and this is 6 ohm. Okay, so if I say this 2 is my P and this 6 is my Q, then this 4 is my R and this 12 ohm is my S. Okay, so what is P by Q? The P by Q is simply this 2 divided by 6. Okay, what is that? 1 by 3. If I calculate the R by S here, that will be 4 divided by 12, that is 1 by 3 here. So P by Q and R by S, these two are equal. So this is a Wheatstone bridge. So we can just omit this R9, which is, we can see it as a G. Okay, we can just omit these two. Okay, and we can just simply write it down this circuit like this way. Okay, write it down this circuit like this way, that just like the G is not there, then capital P and capital Q will be in series. This is my capital P and this is my capital Q, and that will be in series. Okay, this is the A and this is the B, and R and S are also in series. So this is R and this is my S, they are also in series. Okay, what are the values? P is 2 ohm, Q is 6 ohm, it is 4 and it is 12. So 2, 6, 4, 12. So this is 2 ohm, this is 6 ohm, this is 4 ohm, this is 12 ohm. Okay, now here P and Q are in series. So if I try to do the equivalent, what is the equivalent in the upper branch? What is the equivalent in the upper branch? That should be 2 ohm plus 6 ohm. Okay, that means 8 ohm. What is the equivalent in the lower branch? That means the 4 and 12 that are in series. So 4 ohm plus 12 ohm, that means 16 ohm. Now 8 ohm and 16 ohm are in parallel. If we want to find it out the equivalent resistance between the A and B, so 8 ohm and 6 ohm are in parallel. So if I say what is RAB, okay, we can use this formula, RAB equal to R1 R2 divided by R1 into R2 divided by R1 plus R2. So 8 multiplied by 16 divided by 8 plus of 16. So 8 multiplied by 16, 16 plus 8, 16 plus 8 is 24. Okay, so this becomes 3. So it is 16 divided by 3 ohm. Okay, this is 16 divided by 3 ohm. So the options which is the correct one, it is option C. This is my correct option. But here without considering the Wheatstone bridge configuration, if you don't remember the Wheatstone bridge configuration, okay, Wheatstone bridge configuration, you can also apply another one technique is there, which is called the mirror symmetry. Which is called the mirror symmetry. Okay. Sometimes this circuit may be solved with the help of the folding symmetry also. Folding symmetry. Okay. What is that? Very simply, if you don't have any idea of Wheatstone bridge at that time, it can be considered as that here about the registers, about this register, this line, about this line, this circuit is completely symmetric. Okay, this circuit is completely symmetric. Since it is completely symmetric, so we can just omit the register G. Okay, this is another way of work, but since Wheatstone bridge is in our syllabus, okay, so I am just following that one. So 16 by 3 ohm is my answer, and option C is the correct one. Okay, thank you all of you.